All right, so let's look at a different kind of problem. We have a terminal side of an angle, theta, contains the point 8, negative 5. Okay, so let's sketch this. If I looked at my graph and I went out 1, 2, 3, 4, 5, 6, 7, 8, and down 1, 2, 3, 4, 5, I have I went down a little further than 5, but let's just say this is 5. All right, so this point is positive 8, negative 5. Please make sure you're always drawing your triangle with your right angle to the axis, and so your hypotenuse is always coming from the origin. All right, so we know this length here is 5, and this length here is 8, and this is my reference angle. How would I find sine and cosine of that angle? Well, the first thing I have to do is figure out what the hypotenuse is. So I go back to my trusted Pythagorean theorem, and I do 8 squared plus 5 squared, and I get 64 plus 25, which is the square root of 89. Okay, so I found that. And now I'm asked to find, well, what's sine of theta? And what's cosine of theta? All right, sine is opposite, so this side, over hypotenuse. I should have put square root here. And so it's going to be 5 over the square root of 89, but because we know we're in the fourth quadrant, we know that sine is negative. Now, some of you might take care of this just by making this sign here, this side length negative, which I'm okay with. I just have a hard time writing negative next to a triangle side length because you can't have negative length. But if that helps you get the right sign, I encourage you to do that. All right, and cosine is going to be adjacent over hypotenuse, so I have 8 over the square root of 89. All right, I would like you to pause the video and try one on your own. All right, welcome back. I hope you were able to find out that your hypotenuse was the square root of 58. And sine is 7 over the square root of 58, and cosine is negative 3 over the square root of 58. You're in the second quadrant, so therefore sine is positive, cosine is negative. All right, now we're going to go graph on our calculator our sine function. So the first thing they asked me to do is change my window. So I go to my window button. I want to go from negative 60 to 720, scales of 30, and then negative 4 to positive 4, scale of 1. Okay, it's taking a little while here to think. All right, so here comes up my sine graph. All right, some important points to know. 90, that was where it was 1. 180 is where it was 0. 360, it's 0 again. And this is 270. All right, so you can see it repeats its cycle every 360 degrees. When I transform it, this 4 in front of the function does what to the graph? Hopefully we remember from all our other rules that it's just a vertical stretch of 4. So now you take that graph. If I want to graph it, I'm just going to draw in this sine curve here. Instead of this being 1, this now becomes 4. So if it was 1, and that's my parent function. Then now I got to go 2, 3, 4. It's got to come all the way up here. And 1, 2, 3, 4, and all the way down through that same 0, 0 here and back. So it's a vertical stretch of 4. All right, let's look at this transformation. What does the 2 do? Well, that's a vertical stretch of 2. And the minus 30, since it's happening inside, is going to move everything right 30 degrees. Okay, so again, I'm going to take a look at the parent function. I'm actually going to do the transformation function of the 2. So I'm going to go up to 2, down to 2. I'm going to do a little extra. Okay, so some points I needed to know were this is 90, this is 180, 270, and 360. So this is 2 and this is negative 2. So now if you're going to shift everything right 30 degrees, this point here is now over here at 120. This point here is now at 210. 270 is now going to be at 300. I'm just adding 30 to each one of these numbers I already knew. And then 360 here is going to be at 390. And my graph, which was at 0, will now be at 30. So I start there, move it every point right 30 degrees. All right, that concludes our talk on sine and cosine. I hope you have enough to get started with your work.